accepted.
Okay, so first of all, let me say a few words about myself. So my name is Marcin Grzejszczak. Since we're at a Polish conference, I can't really tell this joke that like you can't pronounce my last name because you can. So I'm a developer at the Spring team at VMware. Who knows VMware? Okay, quite like almost everybody. Who knows that VMware is sponsoring Spring? We have to do a better job in marketing as far as this is concerned. So VMware and Pivotal are sponsoring Spring, so I am very lucky to be working in the Spring Cloud team, working on leading the Spring Cloud Sleuth project, so distributed tracing. Also, I'm working on the Observability team, also doing working on the Micrometer project. And Spring Cloud Contracts, so if you're into testing observability, you can reach me out, and you can find me on Mastodon, so toomuchcoding@fosta.org, and Twitter @mgrzejszczak, and you can also follow me, check my blog, toomuchcoding.com. So that's enough about me. So for the past 10 years, more or less, I've been doing libraries, let's say, stuff for the developers. So today, I'm going to transform, which can be very funny to my friends, to a developer working on business value. I mean, business value to me is on the daily basis doing the libraries, but let's assume that for the sake of today's presentation, I will be writing actual business code. So the business topic of today's presentation is going to be steeping tea, brewing tea, right? So this is like a fantastic graph of the system architecture. So we have a request coming to the tea service, and the tea service will make two calls, one to the tea leaf service and to the water service, and those will call the database. So what are the characteristics of all these apps? So first of all, these are Spring Boot free apps. Who's using Spring Boot free on production? Yay, quite a few people, awesome. So all of those apps are instrumented using Micrometer observation, and we're going to be talking about that later. So internally, Micrometer observation instruments various parts of the Spring ecosystem, but not only Spring. Now, since we're using Micrometer observation, we're going to get metrics, and we're getting metrics because we are using Micrometer core. We will have tracing because we have Micrometer tracing. And now, for this particular demo, the tracer we're using is OpenZipkin Brave, but you could plug in OpenTelemetry. That doesn't really matter. So these are the main characteristics of the apps as far as observability is concerned. And now, time for a poor man's version poll. So raise your hand if you know what distributed tracing is. Who knows what distributed tracing is? Okay, a lot of people. So I don't have to go to very, let's say, big details of that. And now, are you using observability, whatever that means, in production? Okay, quite a lot of people, which is good. For the rest of you, like, it's high time you start seeing what's there in production before the clients of your app tell you that. Like, hey, your app is down. Okay, so time for the Tea House demo. So I'm the developer working with the Tea House app, and I want to show you the UI, the reactive UI we've managed to build, I've managed to build. So that's it, right? This is the 23rd century UI, which is reactive. Why is it reactive? Because it reacts to the click. So we can pick the tea leaf, for example, sencha, and we can pick a water size, and we can steep it. There you go. So that's the best I can do. Truth be told, I didn't even write this. Somebody else did. So I wouldn't even be able to do this. But let's say we have the fabulous UI. It tells us how to properly brew the sencha tea in a large cup. So we can check some other things like Yurko, whatever, size small. There you go. So I guess this is like around 300 people here. So if we brew a large English breakfast, everybody's going to take 1 milliliter, and we should be fine. So the way to steep it, That's a bizarre thing. Internal server error. Let me click a couple of more times. No. So most likely, sorry, I have a technical problem with the browser. Let me refresh the browser and click it again. Okay, that's not good. I wonder what that means, internal server errors. Most likely, there is a server error that is internal, right? So we need to somehow try to fix it. So the way we could try to approach that is maybe look into the metrics, the observability. So I am lucky to have, completely by chance, a dashboard for the T-service application. And what we can see to the left, hopefully you can properly see it, yeah, is the T-service latency. So we can see various percentiles of the latency of our whole system. That one is related to the T-service application, so we are on the edge, right? And we have the T-service throughput. So we see that there is like 4.6 and 0.4, around 5 requests per second being sent, and the vast majority of them is successful. And there's a couple of those that are, related to an error. We can see different types of T that is being steeped, and to the bottom we can see a heat map. So that shows, let's say, in buckets, what were the latencies of different requests. So the way we see it, I mean, okay, we had an exception. There are certain exceptions here. Let us see if those related to the English breakfast are, that common. But maybe it was just me. Maybe I clicked something wrong. So the way to do it is, for example, we can go to the service that is responsible for storing logs, because today we're going to be talking about the infamous 3 pillars of observability, so logs, traces, and metrics, which by themselves, if they are considered separately, they're of big value, but it's much better to think of them as something that you can go between, dimensions that correspond with each other. So to begin with, I will search for all the logs related to error. And I'm going to run the query. Where's the button? There you go. So yeah, there is a lot of errors, and one of which, let's pick a random one, is tea leaf with name resource not found, English breakfast. That sounds okay. So we have logs that were sent by my apps to the consuming service that has managed to parse the logs, and now I can do something about the logs. So I can click on the log. If I go through the whole stack trace, I will see that I can jump to the distributed tracing view. So for those who don't know what that is, in essence, let us assume that when the request comes in and it flows through various apps, a certain identifier is attached. Let's call it trace ID. And then this identifier, whenever the hop over the network happens, gets propagated. So what you can do is then list all the logs from all the apps that correspond to this particular trace identifier. So let's do it right now. Let me close the log. Oh, I made it too big, I guess. Oh, close. So what we have here is the graph representing the trace view, so the flow of the request within the whole system for that particular trace identifier. So now I can see that there's an exclamation mark, so there was an exception. Fair enough, we're going to look into that. We can check the node graph, which says that, first of all, we had a T-service request coming in. Then we made 2 client calls from the T-service to the water service and the T-leaf service, and those were actually going to the database because we have a connection. We made a query, we got the result set, and we made a query and got the result set. Fair enough. So that's nice. So now what we would like to do is to understand, reverse engineer, so to say, what happened for this particular request that led to an exception. So we start with the T-service. We see that there was no exception on the water service side, so we can ignore that. We have an exclamation mark here. So if we click on this, we are clicking on, this is called a span. So a span represents a single unit of work. In this case, that's making a receiving an HTTP request. So what we can see here, if we look at the attributes, we can see that there is indeed an error with resource not found. we can see which URL it was related to, and the status codes was 404, which is already something. We can also click on logs for this span, and that way, if we do all this first, we will have all the logs corresponding actually not to this span, but to this whole trace, put in a chronological order. Who of you is still SSHing to machines and grepping for errors in the logs? Don't be shy, we're friends. Okay, far too many people. Far too many people. Don't be doing this. This is much better. I mean, joking aside, if it works for you, then okay. But I guess we're in, in such a place in history that we can move forward. Forget about those, past events. By the way, if you can SSH to production systems, you can also accidentally delete files. Who deleted files on? Okay, don't raise your hand. Don't do it. Okay, so what we have here is we can analyze the logs. I'm going to ignore that for the time being. Now where is close? Close. There you go. So we got 404. So the only thing that comes to my mind here is that we got a request and we went to the database. So let's check it out. So we have a connection. We made a query. What was the query? Okay, select from something. Give me the English breakfast, like where the name is English breakfast. Fair enough. So now let's look at the result set. JDBC row count 0. That's unfortunate. So as far as I understand, we tried to retrieve some information related to the English breakfast from the database, but there was nothing there. So except for the fact that we made a fabulous UI that is fully reactive and responsive and Kubernetes, we have actually forgotten to put proper data in the database, which is kind of sad. So before we try to fix it, another way of getting to this place would be, for example, that the user files a ticket saying, hey, something is wrong, I have this stack trace, and then you get the trace ID, right? So what you could do is copy this trace ID here, and then ask yourself a question, is it an incidental thing? Or did it happen more times, more frequently? So what you can do is for the given span, let's say with the given tags, you can go to certain metrics that would show you, for instance, the throughput. And if you do that, and now let me find the time here for the last 15 minutes, you can see the rate of a given metric. In this case, this is the server-side request metrics, for the given tags being method get, such a URI, such an outcome, such a status, showing you the rate of those things happening. So here you can see that it was not an incidental thing, that the rate is pretty, it's fluctuating, but it's quite a lot. So that means that we got those client errors for the missing entry in the database quite a lot of time. And that makes sense because there's no entry in the database. So before we fix it, let's try to see what we've managed to do so far. So we saw that there was a problem in the UI, or it was told us by our users. We went to the metrics. We confirmed that there seems to be a problem with the with some exceptions. From that, we went to the logs. We checked one of the error logs. And from the logs, we managed to go to tracing. From tracing, we managed to understand what's going on, reason about our system, and then we thought that the problem might be with the missing entry in the database. From tracing, we went to metrics to double check that the thing is actually a global thing, it's not incidental. And also, from tracing, you could go back to logs to find all the logs that correspond to the given trace. So this is the beauty of observability, when you can quickly go between those dimensions and reason about the system as a whole. Okay, so what we're going to do is try to fix it. Completely by chance, I have a request that I should send to enter the missing English breakfast thing in the database. So let me run this. And we got a 201 and all the links related to the English breakfast. So now, if we go back to our fabulous dashboard, in a second, we should have proper results. We shouldn't have any issues related to the server error. Let me now quickly run one more thing. Don't look here. Okay, so let's check one more thing. So what we could do, because it's really kind of bad that our users tell us that something is wrong, or you accidentally click something in production and you say, oh, that shouldn't be happening, right? So we should be notified by something telling us that there is a problem. So what we could do is create an alert. So that alert could be, by the way, this is not a presentation about showcasing Grafana. It's just a tool that serves its purpose. So I'm not a Grafana expert. I'm not a Prometheus expert. So it's not about that. So for sure you can do stuff better than I do. It's about some concepts, right? So we were talking about the 3 pillars as a concept. Now we're talking about alerting as a concept. So what I could do here is say that give me an outcome, which is a server error. And now if I run the query, we can see the rate of server errors. And now you can see, so when do you think, at what rate should we start notifying, at which rate of errors should we start notifying that there's something wrong in our system? Any guesses? Who would say greater than 0? Okay, so there's like a couple of people. So let's do 0. So what you're saying is, if there's at least one exception, get notified. Who in their company has those exceptions that are like, we know them. There's never time to fix them. Okay, raise your hand. Of course you do, right? So 0 is fine in an ideal world, but there's like, oh, yeah, we know this exception. It's been here for 25 years. Just if you try to fix it, everything else blows up. Don't touch it, right? So you know your rate. Maybe in your case that should be 0.1, right? And that way, if it goes above that, oh, that's more than the usual. We should do something about this, right? Okay, so I guess that could theoretically conclude my presentation. What is this? Wait a second, because. Apparently something is wrong here with the latency. So we do have success of 5, but there is like an increased, did I step on a cable? No, I don't know, like something is wrong. We have an increased latency. So that's highly unfortunate. So we have no errors, full success. Grafana is for sure broken. Let me refresh it. No. Heat map, okay. So the heat map tells us that the buckets moved up. So we used to have, like the max was what? The max was 33, now the max is 200. So that's super unfortunate. So something happened within our system in the past 5 minutes. I wonder what that was, that introduced the latency. So how can we try to reason about that? This is much more difficult than the error case, because with the error, you know exactly what happened, because you have the stack trace, the error happened, that's it. Here, you have to, it is more complicated than that. So when you look at this graph, you can see those little triangles and the annoying pop-up. That's called an exemplar. What is that? Whenever you gather a metric, I mean, there is some logic behind that when that happens, but let's simplify this for the time being. When at certain time, when the metric is gathered, we will check, oh, and by the way, is there a span present in the same time? If that's the case, we're going to attach this tracing information to that particular metric. So in this case, for example, we can see a trace ID. So what we can do, theoretically, is to take a trace from before the latency got introduced and check it against a trace after the latency got introduced. So let's do it. So let's try to, come on, click it somewhere around here. Okay, query. Now let's pick another one from after the calamity. Now we can split the view. And now what we have are 2 traces that we can look at the same time. One before latency got introduced, 26 milliseconds. One after, 180. That's highly unfortunate. So if we look at the graph like quickly, we can see, you can't see much because of the resolution. Let me move this here. So the water service used to be 3 milliseconds, now it's 160. So that's quite bad. There are no exceptions, and we assume, because like we picked one trace, so this might be incidental. we see that most likely there is a big problem, around 100 milliseconds of latency in the database. So let's try to confirm that. So what we would do is we would go to our dedicated dashboard, Spring Boot dashboard for the water service. So let's try to analyze one by one cases that can lead to this latency. So basic statistics, everything seems green and flat. CPU usage seems okay-ish. Processed open files, like everything seems to be okay, nothing out of the ordinary. JVM statistics, nothing out of the ordinary, flat, normal spikes. Okay. GC, okay, there were some spikes, nothing interesting. Throughput, 5 with 200, okay. We have the latency on the HTTP side, but that's expected because we are assuming that the database is causing the latency, right? Okay, so let's look at Tomcat. Okay, Tomcat is okay. Hikari, the database. Ah, there you go. So we used to have around 5 milliseconds for usage or creation. Now, for usage, we have 100 milliseconds of latency, which means that we have managed to somehow introduce, or there was a latency happening on the database side. So what can we do about that? We have a couple of things we can do. One is, of course, file a ticket to the database team saying, or network team saying, hey, there's something wrong. But let's try to fix this right now ASAP. So what we can do is to introduce caching. And since we are in the, let's say, demo scenario, I will not do it in a proper way, meaning introduce caching, create a new instance. Since we're using Eureka, then we would have 2 instances running, one with caching, one without. Deregister the one without, wait for the client caches to purge, and only then kill the app. What I'm going to do is I'm going to kill the app ASAP. Okay, so let's go to the water service. Main, Java, repository. And I'm going to introduce caching. So add cacheable water. Now I'm going to do some dirty hacks saying kill -9. So those who have access to your production systems to SSH, I guess you're doing that as well, right? Kill -9, there you go, like a boss. And now let's rerun the app with caching. Let's index JDK. Let's build the app. Let's build it again. Okay, the app is starting. Okay, there's a lot of logging. Let's ignore that for the time being. And let's get back to our dashboard, where it will take a while. Of course, we have a spike in latency. We have a drop in success, right? Because I have killed one of the apps and restarted the second one, restarted it with the new code. So for some time, there was no app, let's say, running. So let's wait for this to refresh. And in the meantime, let's summarize what we could have done to prevent this or get alerted, and what we have done so far. So in terms of alerting, what we could have done is create an alert over the Hikari connection or Hikari-related metrics, which makes a lot of sense, I guess. We could be more specific, because we could also do it, for instance, on the Spring Data repositories if we want to, because Spring Data is also instrumented using Micrometer observation. Thus, you get metrics out of that for free. I mean, even if you were using the previous versions of Spring Boot, you had those metrics out there. So now we can see, oh, there you go. So it works. So we have, again, a success of 5, and we have a drop in the latency. So that went quite smoothly. So I'm super surprised because the demo went fine. So now off to the second part. So maybe one more thing to conclude here. So we have successfully jumped between the 3 pillars, metrics, tracing, and logging. We have managed to correlate them together, visually understand what's going on about them, and let's say produce some meaningful conclusion out of it. So now the question is, how does it all work? Let me click here so you don't see the logs. So demo time. Okay, so how does it all work? With Spring Boot 3 and Micrometer 1.10, we have introduced something which is called the Micrometer Observation API. So in Micrometer, if you go to the Micrometer I/O page, we used to have the slogan, SLF, Micrometer is like SLF for J, but for metrics, right? So you, let's say, use our abstractions, and it doesn't matter which backend you're using, because that's a configuration or implementation detail. Your instrumentation shouldn't change. So with Micrometer 1.10, we changed the slogan to SLF for J, but for observability, because we no longer just take care of metrics. Micrometer provides the observation API that allows you to instrument once and provide multiple benefits out of it. What does it mean? So let us assume that if we go to the controller, water controller, there is this find by size method that uses a water fetcher. Water fetcher is just an interface that takes in, it's pretty much a function that takes in a string and returns an optional water, right? And the default implementation is the one that uses the Spring Data water repository that will call find by size, and that's pretty much it, the simple implementation. So let us assume that you have similar code in your production systems where you have business logic, some services calling some other services, etc., and you would like to add observability there. Of course, one way is using the aspects, but let's say for some reason you don't want to use an aspect, or you can't use an aspect, or even if you use an aspect, you would have to do some interesting things to do it, instrument your code a couple of times, as many dimensions you have, like metrics, tracing, maybe logging separately. All of that would have to be done separately. More or less like this. So we have water service. Let's start with tracing. Water service tracing. So this is a class that wraps the water fetcher in such a way that it will add a span before and put it in scope. I'm going to explain that in a second. So here we are using Micrometer tracing, which is an abstraction over various tracers like Brave or OpenTelemetry. So here we create a span. So we create a span, which will be the child span of the MVC span. It has a name, find by size, and you give it a tag, which is a high cardinality tag, which can vary in time a lot. Now, you have to start a span, and you put it in scope, which means that this span's tracing information, like span ID, trace ID, will be put into the log statements, for example, of this log. But then you can say, hey, the logging is another dimension of observability. I would like to do it separately. And you're right, but I'm not going to add a third one here because I want to simplify things. So normally you could create another dimension for that. And this function is the actual logic that we'll call. We're going to come back to that in a second. And here we are doing an event. Event means annotating a span with like information that something happened at a certain point in time. If there's an exception, you have to mark the span with the exception. And remember, at the end of the day, you have to close the span. Okay? This is tracing. So far, so good. So now, time for metrics. You have to wrap the same piece of business logic with metrics instrumentation. So we're using Micrometer here. We are creating a timer with a given name, with a given set of tags. And now we are calling record, which wraps this lambda with, let's say, with timing information. Okay. Now you have to glue the two together. So if you want exemplars, tracing has to go first. So first of all, you have tracing. That takes in the function, which is the metrics, which takes in the function, which is actually calling the database. Now, if you had the third and the fourth and the fifth dimension, you would have to glue this together if you're doing this manually. I'm not saying this is a bad thing to do, but, I have this important quote. You will have to do it for your business logic, because you can say, hey, I have solutions out there that are, for example, agent-based, and they will instrument my code. Or even, like, it doesn't have to be agent-based, but my code is getting instrumented. And you're right, but it's typically for the infrastructure pieces, like REST template, MVC filters, etc., etc. Those are out of the box instrumented, but we're talking about your business logic. Let's say those solutions have no idea about your business logic. So you have to instrument this every single time manually or via some aspects. So let's see if that's going to work. So we have a service here. We have to remove this service. And I'm going to restart the app. Stop and rerun. So what we expect is to have a trace span, which is going to be called find by size. And we expect the metric water by size. OK, so I'm going to do it in a lazy way. Stop. I'm going to see here we will have the child span trace ID injected. This is the text, and we can see the trace ID over here. I'm going to copy it here, go to tempo. I'm going to close where do you close? Close this, put this here, and search. There we go. So now we have it. And here we have the find by size span. Fabulous. So we have the attribute size small, so we've managed to create the span. After 1 second, we got water by size calculated. Great. So now let's take a look at the, let's explore and take a look at Prometheus. I think the metric was called water by size. There you go. So we've managed also to create a metric. Great. So great success. But the thing is, the problem we see here is that we had to instrument this a couple of times, right? So there has to be a better way. And that better way is to use, in my opinion, Micrometer observation, because I am writing the project. So what we can do is, assuming that you have aspect, let's say, registered as a bean, you can register your aspect like this, add observed. You give it a name that will correspond to a metric name, and contextual name that will correspond to the span name. And you can provide some low cardinality or key values over here. But you can say, hey, you told us about the aspects, right? So it's not fair. Fair enough. So let's take a look at the API. So what you can do is create an observation and give it a name. So that will be the metric name. Set the contextual name, which is going to be, at the end of the day, the span name. You can give it low cardinality key values that will end up in metrics and in traces, in spans. And you can give it a high cardinality key value, which will end up only in spans. Because if you push high cardinality data, this kind of data means that it can vary a lot in time. You can break your metrics backend. You have to start the observation and put it in scope. Sounds familiar? That means that, for example, for spans, tracing information will be put in the logs. You can have an observation create an event. So for spans, that will be an annotation on a span. For metrics, we're going to create a counter. Here you can store an exception on the observation and call stop. So you can say, okay, that's a lot of coding. We would definitely want something easier. No problem. You can just call the method observe, which does everything for you, right? So essentially, it starts, it puts in scope. If there's an exception, it marks the exception. At the end of the day, it's going to stop the observation. Okay, so let's try to run this thing now. So let's change the service. Let's comment it again. So what we expect right now is we're going to have two spans and two sets of metrics. One is going to be water 2 by size, and the other is going to be water 2 child by size. So let's wait for this to start, and we wait for this will have trace ID. Stop it. This will have the trace ID. Okay, there you go. We jump here. So now we should have the trace. Okay, so what we have now, find by size, it's here, and then we have water by size. So one from the aspect, the other one from the API. And automatically they know that there is a parent-child relationship, and all the tags are there. Like this is for the aspect, so we automatically register the class name and the method name. And for the water by size, for the API, we see that we have all the tags that we put there. Now, for the metrics, it was like water2 by size and water2 child by size. So those are there. Great. So we've managed to do the instrument once and get multiple benefits out of it. But the question is, how does it actually work? Like, where is this metrics and tracing happening? So whenever you have those observation methods like start, stop, or was it end, error, open scope, close scope, etc., we have a handler that reacts to these events. And this handler is called observation handler. Observation handler. So you have on start, on error, on event, etc. And what it gets is a context. Context is a mutable map, essentially, that you can extend, let's say, to this class and create your own implementation. In essence, a handler needs to know what to do on start, on stop, and when to act. So you have a method supports context. So for example, you can want to have handlers that react to all observations, like log everything out. But you want to have maybe an observation handler that will react only to those observations related to HTTP calls. You can also do that. So how does it work? First of all, you need to create a context. It's not necessary, but it's useful. So you have water fetcher context. In my case, that's just the additional information I want to have is the size of water and the class of the water fetcher. And then you can create your handler. So let's say that you want to add a different dimension. In my case, different dimension would be I want to start logging things out. So on start, I say, hey, tell me what class logged this out, right? And I want this only to work if the context is of water fetcher context type. So I'm limiting the scope of this to this particular type. Another custom handler you can think of, I didn't think about that, is that Jonathan Ivanov, who has created this T-House app, created on a different branch, believe it or not, a custom handler that will play MIDI sounds wherever there was an exception in this app. And there are some drums, some trumpets. Like, I don't think you should be doing this in your production code, I guess, but it's one way of adding the handlers. You add another dimension, a music dimension to your system without changing the instrumentation code. So now in order to add this, you just pass in the context that you previously create, and your handler can now react to it. So let me quickly add this. And let's see if in the logs we will not see the handler-related code. I guess not, because I've forgotten to add it as a bean. Wait a second. Stop. So observability configuration, and I'm adding the observability handler as a bean. So let's wait for that. Come on, come on. So now in the logs, we will start seeing the handler method, handler text. Oh, there you go. So you can see handler on stop, on start, right? So here we can see now that we have added the additional dimension for the logs. Okay, so another thing, almost the last thing I want to talk about. Oh, there's one more thing. You have two additional things that you can do. Let's say that you would want to add a tag, for example, the environment name to all the observations. It's as simple as using the observation filter that allows you to mutate a given context. You can set, hey, my environment is dev, right? You just register it as a bean. Again, so this is, you're not modifying your instrumentation code. That's a configuration problem, configuration concern. Also, you can use a predicate where you say, you know what, those actuator observations, I don't like them. I want to, ignore them. So you can do a predicate that given some information, like a name of the metric, the observation, or the type of the context, you can decide that I want to ignore this. So now you can say, okay, we are building internal libraries for our users within our apps. Most likely you have such teams. Or you can say, hey, so do I understand it correctly that, for example, for REST template instrumentation, I have to file a pull request to Spring that they modify the current tags because they have the tagging in the instrumentation code contains the tagging information. That wouldn't scale well, right? I mean, having all this information, like this is the low cardinality thing, this is the contextual name. This is a metadata, let's say, issue. It shouldn't be in the instrumentation itself. So what we believe in is that you can separate those concerns altogether. So you have something called an observation convention that is containing metadata information about your observations. So you tell it when it should be running. So for example, only for water fetcher context. And then you can reuse it to provide some additional metadata. Now, the question to you is, who of you likes writing docs? Anybody? Like one? Okay, one person. Thank you. So one person likes writing docs. I am a fan of such an automation that the docs can be written for me automatically. And I'm not talking about ChatGPT, because that you have to really carefully read it again, because that's containing a lot of misinformation. I'm talking about generating docs from your code. For example, ASCII doctor documentation. Yes. So what we can do is, first of all, define our observations in such a way that we create an enum that implements observation documentation. We tell it that we have a single observation that has such low cardinality keys, such high cardinality keys, such events. Low cardinality keys are the following. There's an environment. There's some description of this environment. Then you can say, I have high cardinality keys. There's the description of that. I have such an event, and there's the description of that. And there's the name and context. So you describe everything. And you also say that I have a default implementation of the observation convention. So if the user doesn't override this, this is the default. So what is the default? The default, for example, will tell you that there is one low cardinality key that we mentioned, environment. So environment with value development. There is a high cardinality key, water size, with the value context gets size. The name of the observation should be water-free, find by size, and the contextual name can change. So the span name, let's say, can change. Typical case of a different span name is HTTP communication. You have, for example, post, get, patch, right? The name of the method is there in the span name. So this is a very similar thing. So why all the hassle? Because that way, if you use this is the whole instrumentation code you have. So you create a context, you use the documentation, and you say, if the user provided their own custom observation convention, which can be set via a setter, use that. If not, use the default, and then observe. So now, the instrumentation code is as small as possible. You tell it when to start, when it should put some stuff in scope, and when it should close, right? Maybe you can put also an event there. But the tagging is a separate concern. So if this is Spring, most likely, if you register a water observation convention bean, you will override the defaults. That way, the users, this is exactly the same logic as we do with, for example, REST template or servlet-based instrumentation. We give you interfaces that you can implement so that you can change the tagging mechanism, add some stuff, create from scratch, etc. Change the name. There's a different way. There are different ways to do it. Okay, so let me quickly rerun this because we're almost out of time, but I will manage to do it. And in the meantime, I'll show you one more thing, because somebody mentioned ASCII doc. So if you use the Micrometer docs generator project that contains a main class that you can run and provide some information to it, like where is your source code? Where is your source code? What should we include in your source code? Where we should output things? If you give us that, then automatically we will create a couple of ADOCs for you. So for example, conventions ADOC, hopefully you can you see that? More or less you can see. So it creates all the, puts in the table all the observation conventions in found. For metrics, it will create the, let's say, catalog your metrics, the ones that you find within the observation documentation. With the provided Java docs, provided metric names, it will provide all the key, all the key values, and the same for spans. So here you can see that the spans are defined. What is the span name? Which observation convention should be used for that? And also what the events are. So if I didn't mess anything up, we should now have, if we go to the default, we should have water-free find by size and some bizarre span name for the other scenario. Okay, so let me search for this. Okay, so we have find by size small. This is the name of the span, right? And for metrics, we should have water-free. And there it is, right? So we have separated instrumentation from the metadata. Whew, okay, I managed to show you everything, I guess. So now let me quickly, come on. No, I don't want to file a pull request. Let me quickly go to the live coding. Okay, so we've managed to go through the following things. So I've shown you why there's a problem when you have multiple APIs to do instrumentation. One for metrics, one for tracing, the other for logging. We have no idea what's going to happen next year. Most likely there's going to be a fourth dimension, there's going to be ChatGPT dimension. So imagine using a fourth or fifth API to actually instrument the same code that you have. What you can consider using is Micrometer observation, which allows you to instrument once and you benefit multiple times out of it. I've shown you the aspect, I've shown you how you can customize things using custom handlers, filters, predicates, and I've shown you how you can automatically document your stuff. Check the documentation, so micrometer.io/docs. You have to the bottom information about micrometer observation and micrometer tracing. And micrometer observation is getting a lot of traction recently, and more external projects not related to Spring are starting to use it. Okay, so we have 2 minutes for questions. Any questions? Okay, so either I did a fantastic job explaining things, or quite the contrary, and you're shy to ask. So if you're shy to ask, you can come here. We have like still 2 minutes, or reach me out later at the conference. And I think that's it from my side. Thank you very much.